This is a fantastic solution.
First of its kind.
This system can be designed with multiple finishes.
It's an emerging trend that's coming out.
So we have several roof models, as you mentioned. The SRJ and the SRJW is a model that is typically 1 to 16 inch joint opening. It's basically a sheet metal cap or Z shape. We've been using that system for many, many years. It's been a very reliable product. And then we had the Mark system, which basically started at 36 inch joints and up to 48, very large, seismic, base isolated, large movement joints that could move tension compression as well as lateral shear. So in between those two ranges, there's this 12 to 30 inch joint opening that needed the functionality of the Mark system, but it needed the look of the SRJ system. Mm-hmm. So this is our LSRR, which is a lateral shear roof to roof cover, and then we have an LSRW, which is a lateral shear roof to wall cover.
Right. Walk me through the components that kind of make this up, and why are they important?
Well, typically, the base frame is very similar to our Mark system. It's a very robust base member mm-hmm. that actually has your hold down assembly. And then underneath that on the top panel, you'll have the rigid tension compression slider. And that's basically holds the cover down mm-hmm. from wind forces.
So wind loads, snow loads, also any downforce that might happen.
Correct. Mm-hmm. But on this side of the joint, on the roof to roof or the roof to wall, there's what we have a lateral slider. This is where when the tension compression movement happens, if it has any combination movement, this will allow that lateral slip and lateral slide.
So let's focus in on that for a little bit. So you mentioned lateral shear, and I know that's not it's not a movement that we often talk about. However, we know that it's actually pretty common.
Yes.
So it's a pretty challenging thing to plan for. Mm-hmm. Walk us through kind of how that works.
Yep. So this system really likes to be in one straight line.
Right.
But on roofs you do have twists, turns, ups and downs. Mm-hmm. So if you can imagine you have an L-shaped expansion joint or seismic joint, as one leg of that joint moves tension compression, that other leg is basically sliding laterally.
Shearing along that.
Yeah, yep. Along the axis of the joint. And that sliding effect needs to be taken up and allowed because essentially you're shortening the length of the cover. Mm-hmm. You can imagine if you're in between two parapets, you're trying to crush the cover from the ends.
Right.
So this system will allow that movement to occur, along with our factory fabricated transitions to allow that movement, because when you start talking, every project is a little bit different. So right. The type of movement and the amount of movement needs to be accounted for in these systems.
Right, and I think that underscores the importance of having the support that we do from our engineering team. I know they dig into problems and challenges and lateral shear conditions on a weekly basis. What else does our team do behind the scenes to kind of service these systems?
It's very important that the architects reach out early on in the design phase so that we can help them understand the amount of movement that they're trying to accommodate and get the right systems and the right design for the application, mm-hmm. not only for the walls, interior walls, the ceilings, and the roof, especially with the exterior, the building envelope, tying the systems together for water tightness and performance is very vital.